Lesson 8.1, Right Triangles and the Pythagorean Theorem. Many of you have learned the Pythagorean Theorem previously in previous grades, and you've done it actually this year already. So it says, consider the triangle with the altitude CD as shown. Remember, this is the altitude right here. What is the area of the triangle, of the total triangle ABC, and of ACD, this smaller triangle, and explain your answers. So first of all, this is a 45, 45, 90 triangle, which means that if one of the angles is 45, the other one has to be 45 because they have to total the 180. So whatever this side is, 5 square root of 2, this would be exactly the same, 5 square root of 2. And hopefully with that information, you can find the area. And just as a reminder, area of a triangle equals 1/2 the base times the height. So using the Pythagorean theorem, you'd have to know, and a lot of people teach this as the Pythagorean theorem is a squared plus b squared equals c squared. That is not correct. The Pythagorean theorem says if a triangle is a right triangle. And a lot of teachers forget that, and a lot of students forget that. That big if a triangle is a right triangle, that has to be known first. So if a triangle is a right triangle, then a squared plus b squared will equal c squared. There is also the converse of the Pythagorean theorem. Remember, converse is when you switch the order of the hypothesis and the conclusion. So the converse is when you take a triangle and you know that a squared plus b squared equals c squared. So if you ever know that this is true, then you know it's a right triangle. Example 1 is a great example. In fact, it actually has a video step by step proving the Pythagorean theorem. It goes through the whole process step by step. It has you how to solve them, how to make a similar triangle. So I highly recommend watching this video and watching it step by step to learn how the Pythagorean theorem was proven using similar triangles. All right, so let's try it. Still example 1, but try it. Use the figure shown to find AB. So as we do this, keep in mind, it is a right triangle. Check that first, which it is. So a squared plus b squared has to equal c squared. And as a reminder, the side not touching the 90 is the hypotenuse. That is always c. So as I write this equation, I'm going to plug in 12 squared plus 15 squared and set it equal to that c squared. Grab those calculators. Some of you already know these answers, but it's 144 plus 225 equals c squared. I'm going to have you go from there. Solve for this. Once you get that answer, take the square root of both sides because you don't want c squared, you want c. So c will equal the square root of whatever you get here when you combine 144 and 225. Sometimes when you're given a problem, you won't actually be looking for c. So in this case, I have my c because the c is always across from the 90. So that means I'm missing a or b. I'll just call this a and this b. So still set up the formula, a squared plus b squared equals c squared. But this time, I'm going to use capital A so it doesn't look like a 9. My 7, this time, you're not solving for c. You're still going to do the same process. A squared plus 49 equals 100. And again, you can use those calculators if you need to. Subtract 49 from both sides. And you will get a squared equals 51. Again, you don't want a squared, you want a. Take the square root of both sides because square roots and squares cancel those out. So I have a equals the square root of 51. Depending on your teacher, you need to know if that's an acceptable answer or if you need to take the square root of that answer, which would be approximately 7.14. Example 2, application problem. It says use the Pythagorean theorem and its converse. To satisfy safety regulations, the distance from the wall to the base of the ladder should be at least 1/4 the length of the ladder. Well, we don't know the length of the ladder. So you're going to find, using the Pythagorean theorem, what the length of this ladder is. Then you're going to take 1/4 of this length, and hopefully 2.5 is bigger than that. The length of a cross piece of a fence is 10 feet. Why would a rancher use that? So if they knew that this diagonal right here is 10 feet, why would he make this 8 and 6? So something you might want to know is there are some common Pythagorean numbers, and they're called Pythagorean triples, where they're all whole numbers. They're not zero, they're all whole numbers. The most famous is a 3, 4, 5 triangle. So that means A and B are 3 and 4. The hypotenuse is C, which is 5. So in this case, if I have a 6, 8, and 10, isn't that just 3 times 2? 4 times 2? 5 times 2. This is exactly the same Pythagorean triple. It's just dilated. It's a bigger size. So anytime you have a 3, 4, 5 triangle, this is probably the most famous Pythagorean triple. Look for those ratios. Is it double, triple, quadruple the size of a 3, 4, 5 triangle? Then you know it's a right triangle. This is a pretty typical problem. Pythagorean theorem, a squared plus b squared. Find that c squared. When you have a problem and you are asked, is this a right triangle? That's when you're dealing with the converse. You want to figure out if a squared plus b squared equals c squared, then it for sure is a right triangle. But if it's not, if it doesn't equal c squared, then it's for sure not a right triangle. So first of all, you need to figure out what c is. C would be the hypotenuse if it's a right triangle, which would be the longest side. So look through these. Oh, 37. That is the longest side. That has to be C. A and B are interchangeable. 35 squared plus 12 squared. And honestly, this is what you're trying to figure out. Are they equal? So you don't know. You're trying to figure out, are they equal? Work your math, figure it out, see if 35 squared plus 20 or 12 squared, if it does equal 37 squared. If it does, it is a right triangle. If it does not, it is for sure not a right triangle. Although the Pythagorean theorem is something most of you have seen before, the 45, 45, 90 triangles might be totally new. We did one at the beginning of the class, but this is something that's a little bit different. It says, is there a relationship between AB, this total length, and AC, this side length? Well, let's refer back to what I said at the beginning. If this angle is 45, so would this be, because a 45, 45, 90 triangle, those add up to 180 using the triangle sum. This is an isosceles triangle. I know that because if two base angles are congruent, then the triangle must be isosceles by the converse of isosceles rule. So those are going to be the same. Let's just call them x. Okay, and I have to find the relationship basically between x and the hypotenuse. So I'm trying to figure out, what would this be? I really don't have any information, but I still know I can use the Pythagorean theorem. A squared plus b squared, does that equal c squared? In this case, yes, it should, because it's a right triangle. So I'm just going to plug in x. X squared plus x squared equals c squared. And remember, I still don't know c. X plus x, that's just 2x squared, equals c squared. I'm going to try to get c by itself. So I'm going to take the square root of both sides, square root of this, square root of that. Now keep in mind, c squared square rooted just becomes c. X squared square rooted just becomes x. But that 2 still has to stay in there. So I'm going to say x times the square root of 2. Even though I don't know what x is, I do know that this side length over here that we're looking for should equal whatever the side length is times the square root of 2. And what will happen is the hypotenuse relationship on a 45, 45, 90 triangle, you'll always have the side length times the square root of 2. So think about what I just told you. And if we knew that the side length of a 45, 45, 90 triangle equals the hypotenuse. So hypotenuse equals side times the square root of 2. Well, here's 7. And since it's an isosceles right triangle, this also would be 7, which would mean the hypotenuse is 7 times the square root of 2, just by understanding this formula right there. So the hypotenuse equals side times square root of 2. And remember, this only works in a 45, 45, 90 triangle. Same idea, but working backwards. So again, the hypotenuse equals side times square root of 2 because it is a 45, 45, 90 triangle. And I know the hypotenuse is 12 square root of 2. And I'm like, hey, 12 square root of 2, that's like having a number right here. 12 square root of 2, the side length would be 12. Here's the theorem. We just went over this. If you have a 45, 45, 90 triangle, then you have right here the side length, or sorry, the hypotenuse would equal side times square root of 2. If you're given the hypotenuse and you need to find the side length, and it's in the form of something times the square root of 2, that side length would be right here in front of that square root of 2. Example 4 is an amazing example. It explains the relationship of a 30, 60, 90 triangle. So originally in this lesson, we had Pythagorean theorem. It works for all right triangles. Then we talked about rules if it's only a 45, 45, 90 triangle. Now we're talking about rules if it's only a 30, 60, 90 triangle. So I'm going to give those rules. You can go through and look at this lesson or look at the step-by-step instructions, which I highly recommend. But here's the bottom line. Whatever this short side is, and I'm just taking just one of these sides right here as a 30, 60, 90 triangle. Whatever the short side is, the hypotenuse is 2 times the short side. And this longer side is the short side times square root of 3. Now keep in mind, this side is the long, so the long equals short times square root of 3. This side is the hypotenuse, which is 2 times the short. And the shorter side is always the one that's across from the 60. Because if the 60 degrees opens up a little bit, or the 30 degrees, the 30 degrees will only open a little bit. The 60 degrees will open up more, and the 90 will open up even more. So that means across from the 30 would be the smallest. Across from the 60 would be like the medium length, and across from this 90 would definitely be the longest, which is true since it's the hypotenuse. So let's think about what I just told you. I said the hypotenuse is 2 times the short. The long side is the short times square root of 3. And then this right here is the short. And I know that because it's across from the 30. So if I was trying to find each of these, first, I would need to make sure, okay, I've got the short. What can I find next? In my opinion, the next easiest one is finding the hypotenuse. Hypotenuse equals 2 times short. Take that 2, and the short length, you know, is 6. So the hypotenuse equals 12. Now the long equals the short times square root of 3. Well, the short is 6. Square root of 3 is still square root of 3. So the long side equals 6 square root of 3. Okay, this one's a little bit trickier. We're not given the short side. So here's the short. The long equals short times square root of 3. And the hypotenuse equals short times 2. Well, luckily in this problem, it is set up in the form of something times square root of 3. So this thing in front of the square root of 3, that's the short. Now, it's not always going to be that easy. It's not always going to be seen that way. So if I wanted to, or if I needed to, I would do this. The long side is 9 square root of 3. And I'll just say the short is s, square root of 3. I need to find that short. So I'm going to divide by whatever I have here on both sides. And when you do this, in this case, notice the square root of 3's cancel, and you do just have 9. So if you have it in the format, or the long in the format of something times square root of 3, yes, you can do that. So I do have the short as 9, which means the hypotenuse is the short times 2, which means the hypotenuse is 18. Here is the rule, the theorem, 8.4. It says, if you have a 30, 60, 90 triangle, remember, it has to be 30, 60, 90, which is the angle measurements. Then the side measurements are this type of relationship down here. AC, which is the long, would be the short times square root of 3. AB, which is the hypotenuse, is the short times 2. And I would write this here. I almost always write this as the short. I put long equals short times square root of 3. Hypotenuse equals short times 2, or 2 times short. So this problem says Alejandro needs to make both the horizontal and vertical supports to create this ramp. So he has the 10-foot board or whatever he needs. He just needs to cut these two pieces, and he has a total of 12 feet right now. We need to determine if that 12-foot board is long enough to make this side and that side. So let's do some math here. Let's set this up. We know right away it's a 30, 60, 90 triangle. So let's find that short side. It's always going to be across from the 30. So this is the short. This is the long, which is short times square root of 3. And this is the hypotenuse, which equals short times 2. So I'm just going to plug this in over here. Hypotenuse is, and some of you might already know the answer. The hypotenuse is 10. So if I need to find the short, I'm going to divide by 2 on both sides. So my short equals 5. That's one of the lengths. I've got a side length of 5. But then the long side is short times square root of 3, 5 square root of 3. And that, I don't know what that is. So I'd grab that calculator, figure that out, and you should get roughly 8.66, let's say. Now, do these together fit on a 12-foot board? Oh, 5 plus 8 alone is 13. And then you have these 0.6s. Yeah, this is too much. So that 12-foot board will not work. Olivia starts an origami paper crane by making a 200 millimeter diagonal fold. So here it is across this square. These are both the same. We've got a 90. So it's a 45, 45, 90. This side is going to be S, which means this side is also going to be S. So we're thinking 45, 45, 90 rules. Those rules say that the hypotenuse equals the side length times square root of 2. This is a perfect example. That's not like the pretty setup. So I'm going to take this hypotenuse, 200 equals the side length times square root of 2. See, there's no square root of 2 on this left side. So it's going to get a little ugly. And at this point, depending on what your teacher wants, you could simplify this radical by rationalizing the denominator, or you can grab your calculator and calculate that. So make sure you know by your teacher's standards. For now, I'm letting my students just divide it out on the calculator, and it should be 141.42, let's say. That is the side length. So 141.42. If that's the side length, which I have, and that's one of the answers I need, I also need the area. Keep in mind, the area is base times height. And because it's a square, I'm going to take area of a square equals base times height. And in this case, the base and the height are both 141.42. So you can figure that out. Try it. 30, 60, 90 triangle. Remember the rules. So, and if you have to look back, it's okay. Look back to look at those rules. You'll need to know them. Here's the short. Here's the long, which is short times square root of 3. And the hypotenuse equals short times 2. Again, not a number that's easily figured out since it's not in this short times square root of 3 format. So let's do some calculations. Long equals short square root of 3. 28 equals short square root of 3. Divide by square root of 3 on both sides. And again, ask your teacher, do they want you to rationalize the denominator, or do they just let you grab the calculator and figure that out? But if not, to rationalize the denominator, you need to multiply top and bottom, numerator and denominator, by whatever this radical is down here. So I'm multiplying basically by 1 because I have square root of 3 over square root of 3. That's just a different form of 1. And when I do that, these square roots, because a square root squared is just that base number, I'm going to get 28 square root of 3. Notice I put the square root of 3 behind it. And the denominator just becomes that base number inside the radical. Because square root of 3 times square root of 3 is actually square root of 9. But square root of 9 is 3. And that's how you got that answer. So this is the short side. And when you take this short side and multiply it by 2 to get the hypotenuse, I'm going to have hypotenuse equals short times 2. Well, oops, short times 2, sorry, times 2, just regular old 2. The short is 28 square root of 3 over 3 times 2. When you do something like this, you're actually just multiplying these whole numbers, this 28 times the 2. And so you will end up with 56 over 3 square root of 3. Another problem that doesn't have the pretty setup. So I've got a 45, 45, 90. These are both going to be the same length. The hypotenuse is always going to be the side length times square root of 2. So again, this 14 isn't nice and pretty. So I'm going to set it up, which is ironic because you would think 14 is nice and pretty. It's just, what I mean is not nice and pretty. It's not set up with a side length and a square root of 2. It's not a bad number. So 14 equals side length square root of 2. Divide by square root of 2 on both sides. And again, if your teacher lets you leave it like that, grab a calculator, plug it in, you're fine. Otherwise, you need to rationalize the denominator. And by doing that, you're going to multiply by square root of 2 on both top and bottom, which is the reason why is so you take the radical that you have and multiply by an equivalent fraction of 1 with that same radical. Okay, so square root of 2 times square root of 2 becomes 2. And the numerator is 14 square root of 2. And this is the short side. But if you notice, the 14 right here and this 2 down here, they can reduce because 14 divided by 2 is 7. So actually, you can leave that final answer as 7 square root of 2 for both sides that are missing on this triangle. And here's the concept summary. It says Pythagorean theorem and special right triangles. At the beginning of the lesson, we talked about Pythagorean theorem. If it's a right triangle, then the Pythagorean theorem works. The converse of that is if the Pythagorean theorem works, then it has to be a right triangle. And again, these special right triangles, keep in mind, I do it a little bit different, but same concept. Whatever the side length is of a 45, 45, 90, both sides will be the same. And the hypotenuse will equal the side times square root of 2. On a 30, 60, 90, go straight across from that 30. That's the short side. The long side equals short times square root of 3. And the hypotenuse equals short times 2. I hope that helps.